Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful, welcome to Lady Khadija radiallahu anha online college live lesson in A-level maths year 2. Today's topic is parametric equations with sine and cos. Let's take a look. The first equation in the pair is for x, and the equation is x equals sine t plus 2. So that's sine t plus 2. And then for the y, we have the equation y equals cos t minus 3. And what we want to do is produce the Cartesian equation. So the Cartesian equation is where you have just y and just x in the equation, no other letter or variable. So when you're looking at this, you're thinking, well, how am I going to get rid of t? You got the t is fixed within the sine and the cos. It's not very easy to get rid of here. In the previous examples, we could rearrange it, but you can't really rearrange it here and get rid of the t very easily. So you have to use what you've learned before earlier on in the earlier chapter, which is sine squared plus cos squared is identical to 1. So sine squared of an angle, of any angle, plus cos squared of the same angle is identical to 1, can be swapped with just the number 1. And that's really good because what we can do now is try and rearrange these two equations so that I've got sine squared in one of them, cos squared in the other, and so if I add them two together, then I can replace that with just the number 1. So let's try that. Let's take the first equation, have a look at it. Can you think how to rearrange it so you've just got sine squared? Let's start with keeping the sign here, but taking the plus 2 across. So let's take the plus 2 across, and that'll turn into a minus 2. So now I've got sine on its own. I want sine squared, so let me square both sides. So I've got x minus 2 squared on the left. On the right-hand side, sine bracket squared can be rewritten as just putting the square sign within the brackets, and then there's no need for the brackets. So it's just another way of writing it where it's easier to read if you don't have the brackets there. Okay, it means the same thing, sine squared t, which is good. We've got the first bit now. Let's take a look at the next bit. We're going to do a similar thing. Minus 3 can come across, and hopefully you can remember what to do after that. So minus 3 comes across, changes to a plus. And then we can square both sides. So we'll have y plus 3 squared is equal to cos squared t. And now I can use this identity. I can say, look, if I add them together, then I can replace that sine squared plus cos squared with 1. So let's take both equations and add them together, or let's just substitute them into here. So I've got sine squared, which is this bit. So I've got the first bit, which is, actually let me do this properly. So we used x in the general formula. We don't have x here, so after the sine and the cos in the equations we're looking at, we've got t. So let's just use the same letter so you don't get confused. So the identity is for any angle, so we can call that angle t. And now I've got sine squared t, that's this bit here. So I can, let's take a copy of that. So sine squared t can be swapped for the x minus 2 squared. And then similarly the cos squared t that can be swapped for y plus 3 squared. And then the identity can be just replaced with the equal sign, normal equal sign. Okay, and there's your final Cartesian equation. It's just got x's and y's in. It doesn't have any t's or any other variable. And it reads x minus 2 in brackets squared plus y plus 3 in brackets squared is equal to 1. And that's where you can stop. Join me again for more tomorrow. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the mercy and blessings of God.